Hi, this is Hai Xiao Wang, and today we are going to talk about the course schedules too. The problem says that there's an array named prerequisite, and it's composed of some sublets like AI and BI, indicates that you must take the course BI first if you want to take the course AI. So we can just imagine there's a node AI and a BI, and there is an edge uh, from the BI to AI because if you want to go to the AI, you first should take the course BI. Let me better explain the prompt by using an examples. Here actually we can find that one if we want to take the course two, we should take the course one. Uh, and for so we can just uh, imagine that the AIBI here is that if you BI is equal to one and AI is equal to two, because if you want to take the course two, and you should take the course one. So similarly, if you want to take the course four, you should take the course two and three before taking the course four. And then you can, only if you take the course four, and you can take the course five. And so we should return the ordering courses that you should take to finish all the courses. And if not, we can just return empty list. So here we can use the integrates, which denotes for how many inbounded edges of the one node. For example, the 4 here has two inbound edges, which is 2 to 4 and 3 to 4, which means that there are two prerequisites of the course if you want to take the course 4. So we can use the BFS to solve these problems. And the first question is that what's the start node of the queue? Here, the start node is those are those courses that has zero inbound edges, and here is it will be the let me change the colors. This is a 1 and 3. And the reason is that there is no inbounded edges of the 1 and 3, which means that we can take the course 1 and 3 without taking any courses. So we can just use the queue to store the course 1 and 3, and then because every time we will pop the element from the queue, actually we take that means that we take the course 1, and then we updated its neighbors integrate inbound edges. For example, here is the inbound edges of the 2 will decrease by 1, and it will reach to 0. And then we can just append the 2 to our array, which means that we should append 2 to our array. Yeah, and that's the logic behind these problems. And then we just can start our writing our node, our code. We should initialize the integrate arrays with zeros. And G is a graph that stores information. So AI, BI in prerequisite. Um, there is edges a from the BI to AI. So the GBI, yeah, and AI, and the integrate AI should be +1. And for all our, so then we just go through at the first uh, we just go through the integrate. If the integrate starts, if this is a zero, which means that this will be the start node. So we just append the start courses to our queue. And then we just start our BFS part. And RES is dinner for our result. Every time we just pop the course from the queue. This means that we take the course so that we pop it from the queue and we just append the course to our result. And for its neighbor, we should update its integrates by -1. This is because we already take the course here, and so when we go through its neighbors, we should update it by -1. And for example here, when we take the course 1, we should update its integrate of the 2 by -1. Yeah. So if the integrate reaches to 0, which means that its neighbors can also be should be added to the queue because there as that circumstance it has no inbound edges, and so we can take that course without taking other courses. So we can just append to it, and then we'll just go through um, the integrate again, and if integrate and it's greater than 0, which means that it's impossible to go to take all the courses. So let's return the empty list. Otherwise, we can return the result. Let me check it. None courses, so there should be none. Yeah, it's already is a number, so just like that. Let me check. Yeah, it works well. That's pretty much about this problems. Thanks for watching.